welcome to my video channel. So this video, let's solving this question. So this question is not easy, okay? So but it introduces some idea that you can actually you can you can make an arrow to bound this type of sequence, which is really amazing that I seldom think about it. Okay, so let's start. Before I start, subscribe to my channel and leave a comment below. Okay, so let's see the proof. Okay, so this question is very rare that I mean, this is the first time I see this question. So the idea is that you need to do only use this, right, to bound x1000. Okay, so the key step I will guess is first square. Right, this is what I get. Okay, so and I want to. So idea is that I want to connect xn to x0, right? So which tell me that the xn plus 1 square should be written as x0 square plus xk plus 1 square minus xk square, k round 0 to n. Okay, so which tell you that this term x0 square is basically so this is k to 0 and 1 over xk square plus 2 xn plus 1 square. Okay, so x1000 square will be x0 square plus k from 0 to 999 1 over xk square plus 2. Okay, so we start from here and to do the estimation, right? And this term is very easy. This term is 25, right? So 25 plus k from 0 to 999 1 over xk squared and the 2, right? So we got 2 times let's say 1000, right? Because there are 1000 terms. So now you get x1000 squared is 2025 plus k from 0 to 999 1 over xk squared. Okay, so now you get a lower bound, right? Lower bound is 2025, which is a 45 square. Okay, so we proved the first part, which x1000 should greater than 45, right? Because these are all positive. Okay, and the next part is that the difficult part is that what was the point 1 comes from? Where does point 1 come from? Okay, so so from this, right? From this, I know that the xn is increasing. So I should write this x1000 square, give a lower bound, right? So I should pick up the largest term, right? So largest term will be 1 over x0 squared, right? So right. So I should pick up, but let's see. Okay, so one difficult. So the difficult part is that if I only take x0, right, then I would say that this is x0 square and 1000, right? But x0 square is 25, right? So somehow this is too big. This bound is not effective. Okay, so what I managed to do is that I only pick up the first term. Let's say I pick up, let's say k from 0 to 99 and the 1 xk square plus k from 100 and 999 1 over xk squared. Okay, so I do this because in order to get this 0.1 bound, right, I need to know more about this xk squared magnitude. Okay, so this is the expression. So now I need to let's check about 100, right? So let's say I go back to here and change 1000 to 100. So I get x100 squared, which is x squared plus k from 0 to 99 1 over x0 xk squared plus 2. Okay, so the easy idea is that this is 25, right, plus 200 plus something k from 0 to 99 1 over xk squared, right, which is greater than 2 to 5. So from here I know that x100 is greater or equal to greater or equal to 15, right? Okay, so from here that we made enough to get expression. So now 1000 square x 1000 square less than 0 to 5 plus. So now I can change this term, right, to use x 100 square, so less than 100 x 0 square plus 900. There are 900 terms, right? And I check it's 100 square. Okay. Okay, so this term is 2025 plus 100, and so x0 is 25, right? 25 plus 900, and this is 15. Right, 15. So 2 to 4, 2 to 5, and this is just 4, right? And then this is just 4, right? So if you take a square root of this guy, should be less than 45.1. And this is a check that I think you can easily check that it is less than 0.1. Okay, so the idea is that you use this expression, and manage to bound this type of term, and then you can get lower bound and upper bound. Okay, so this is a really cool exercise that to let you guys understand how to dominate this type of sequence. Okay, and see you guys in next videos. Subscribe to my channel. Thanks.